everyone, good to see you all through this social media platform with a new topic, Inter-Integrated Circuit. I am Aiswarya S, Assistant Professor in the Department of Biomedical Engineering working at Emmanuel Associated College of Engineering. So let's begin into the section. So as per I2C, that is Inter-Integrated Circuit, is one of the most widely used communication protocols in embedded systems. Almost every modern electronic devices, from smartphones and laptops to medical equipments and automotive systems, which uses this I2C, that is inter-integrated circuit, to communicate with sensors, memory devices, displays, and other peripherals. Okay, so this is the short note. What is I2C and why it is used? Suppose you are designing a weather monitoring system using a microcontroller. The controller must communicate with the temperature sensor, humidity sensor, OLED display, EEPROM memory and RTC module. So these are under the components which comes under the microcontroller to use for the monitoring systems in this inter-integrated circuit. So instead of using all these many communication wires, the I2C, that is the inter-integrated circuits, allows all these devices to communicate using only two wires. So this is the benefit of using the inter-integrated circuits, because using microcontroller we are using many number of wires for connecting the system with many number of components, but by replacing that with inter-integrated circuit, that is I2C circuits, these all devices can be communicated using only two wires. Okay, so I2C stands for inter-integrated circuit. It was developed by Philips Semiconductors. Okay, so now it is called as NXP. Okay, so now it is called as I2C, but older in 1982 it was called as NXP. It is a synchronous serial communication. Okay, it is a synchronous serial communication protocol. Unlike UART, which uses separate transmit and receive lines, I2C needs only two communication lines. Okay, UART is also two communication lines only they are also using, but they need them separately for transmitter and receiver. But as for this I2C, only needs any of the two communication lines for the communication transferring of data between the devices. Okay, so it is a bus interface communication protocols which incorporated into devices for a serial communication. As I also told, this is a synchronous serial communication protocol. Okay, so it was originally designed by Philips Semiconductor in 1982 and now it is named as NXP. So recently it is widely used protocol for short distance communication. Okay, so this I2C is widely used for short distance communications. These are SDA, that is a serial data line. So two communication lines I have already told, right? The I2C needs only two communication lines, and the two communication lines were SDA and SCL. So SDA means serial data line. Okay, so SDA, SDA, and the other one is SCL. Okay, so as I told, SDA and SCL are two communication lines which are used in this I2C. So SDA means serial data line and SCL means serial clock line. Okay, so this serial data line actually it is used for transfers data, so SDA or SDL. Okay, so it is used for transferring the data, and the SCL is used for providing the clock pulse. CL for serial clock line means it provides the clock pulses. Okay, so the very one important thing is this: both these lines are bidirectional. Both lines are bidirectional. Bidirectional means they can communicate in both direction. Okay, they are bidirectional. So these are bidirectional. Okay. So some of the features are the two-wire communications are used, that is serial data line SDA and serial clock line SCL. Then it is used in synchronous serial communication. Then it is also used in half duplex communication. Again, it is a synchronous communication. Before we have learned that is a serial synchronous communication, right? Then it supports up to 127 devices in 7-bit address. It is used to communicate 27 devices at a time with the 7-bit addresses, and supports up to 1023 devices in connections in 10-bit addresses. So the 10-bit addresses of devices, 1023 devices can be connected, and 7-bit addresses of devices, 127 devices can be connected. Okay, then each connected devices has unique addresses. So each addresses which are not a common addresses which shares each other, but each connected devices has a unique addresses which has a unique addresses. Okay, they are half duplex, simple wiring, low cost and reliable communication. So these are all the features of the I2C, why it is actually used. Okay, so the I2C bus architecture actually has this is the frame format. Okay, so in this frame format you have a start, that is the start condition is given here. Again the address frame is given. In this address frame only it is considered as 7 or 10 bits. If it is 7-bit it is considered as connecting 127 devices, and if it is 10-bit it is connected of 1023 devices, isn't it? Yes, we have seen it in the futures, right? Yes. So next it is given as read or write bit. So only this reading and writing options it will done here. Then the acknowledgement bit is here. Okay, the next to read and write, the acknowledgement bit is considered. Again the 8-bit data frame 1 is considered first. Again one acknowledgement bit is considered. Again the another 8-bit data frame is considered next. Then acknowledgement bit is given. Again the stop condition is applied in the stop. Okay, so this is the normal frame format for the I2C circuit. So let me explain once again. In the start condition is given in the start frame, then a 7 or 8 10 bit of address frame is chosen. If it is 7-bit then it is connected 127 devices, and if it is 10-bit it connected 1023 devices. Then the read and write bit is connected. Then the message passes through the acknowledgement bit, where it is given to a 8-bit data frame 1, and the next it is acknowledged, and again it is given to another data bit frame where another 8-bit is given. Okay, so next is terms. What are the terms actually to have is master. So what are the terms is master, slave, SDA and SCA. Okay, so these are the 4 terms we are using here. That is, device which controls the communication is master. As for an example, if we are saying that in a program there are some head, okay, some master is there, he is actually controlling his subordinates who are working under him, right? Likewise here the master is the device which controls about the whole communication in the network, and slave is the person who responds or who hears or who responds to the master's orders. So slave is the device which responds to the communication given by the master. Okay, so again SDA is serial data line. So data transfer, it is used for data transfer, serial data which is used for data transfer line, and serial clock line, that is serial clock which is used for timing clock line. So for giving timing or giving the pulse or giving the time clock for the frame it is used, that is SCL. So these 4 are the terms or the parts of I2C, that is master, slave, SD and SCL. Okay, so these are some of the terms also. So what are they? Are acknowledgement, NAC, start, again stop. Okay, so these are all the next terms. Acknowledgement, to confirm byte received successfully, that is to acknowledge where the byte we are sending them should ranged or should be received successfully. The NAC means not received properly, that is unable to process. Acknowledge means okay, it is accepted. NAC means NAC means it is not received properly or unable to process. Again start means initializing the data transfer. Stop means terminating the data transfer. Okay, so some other terms are read or write, address and then data. Okay, these are some other terms, that is read or write, reading or writing the command bit which is given. Again address, that is used to the address of the devices. So as I told you, if it is selected as 8 or 10, then according to that selection bit it will use as how many, 1, 2, 123 devices will be connected here. 1127 devices should be get connected, right? So data means data which is used to transfer in the frame. Okay. So these are the terms which are used in this I2C, or the components used in integrated circuits. Okay. Next, the master-slave communication. Actually, what will be done in this master-slave communication? Okay, so in the master-slave communication, a master is given, and then from the master, the data communication is given to the number of slaves in the slave section by using the two communication wires SD and SCL. Okay, like this picture is mentioned very neatly. The master will give the communication protocol communication link to all the slaves present through the two communication wires SD and SCL. Okay. So actually the master will generate the clock, initiates the communication, sends the slave addresses, then controls the data transfer. Okay, so this is the example of master. I'm sorry, this is the process of master, how it is working in that process network, and the best example for this master is microcontroller. Okay, so what does the master do actually? It generates the clock, it initiates the communication, it sends the slaves address for each slave, then it controls the data transfer inside the whole process. Okay, so the best example for master is which one? Microcontroller. Okay, so again the slave, what does the slave have actually? The slave responds only when the address is called. As I told you, the master will give the address to each slave, so the slave will only respond only after getting the address, only after responding, only when the address is called, only after the address gets called by the master, the slave actually responds, because each slave have each number of addresses, right? Unique addresses will be given. So if the master says the message is only for the address number 1, then the address number 1 having slave will only respond to the master. Okay, so examples EEPROB, OLED, temperature sensor, RTC, all these are the examples for the slaves. Okay, because they are giving an output, they are giving a response to the master. Okay. So how does it start? The start condition, how does it begin? So the SDA line will be always in high. Once SDA is low, all slaves will ready for communication. So the SDA line will always be in high. Once the SDA is low, all the slaves will ready for communication. Okay, so then the SDA line will be first becomes higher to low, next the XA line will become high to low. Okay, so first the SDA will only become high to low, next the SCL. SCL means which one? The clock will become high to low. Okay, so how does the address will become? Two address formats actually used here. The most common supports 128 addresses. The 10-bit address is used when many devices are connected. So 7-bit and 10-bit I have already mentioned you, I have told you. So if 7-bit, it is most commonly used, 128 addresses supports panno. Then again for 10-bit addresses, it uses the devices which are connected when many multiple devices are connected. It uses the 10-bit addresses, that it connects actually 1023 devices can be actually connected. Okay. So see, this is the start condition process, that is SD and SCL, which goes up, then it goes down, it goes up and it goes down. So likewise the process turns out and it acknowledges, and then the here it starts, it gets engaged, it controls, it gets acknowledged, gets not acknowledged sometimes, then it is terminated at the end. Okay, the slave actually checks the addresses. If correct, it sends the acknowledgement. Acknowledge means I am ready, like that the slave will actually send. Okay, so the data transfer will then happens there as the master sends one byte at a time. After every byte, the receiver sends an acknowledgement. Okay, so for example, the master is requesting for temperature request and the sensor is giving replies. The sensor actually sends to by the sensor of the slave is 30 degrees Celsius, like that it is giving the sensing. Okay, So as for addresses, if master wants to communicate with any slave, it will send the addresses of the slave to all the slave connected to the bus. I have told you already, right? The master is only one, but there are number of slaves. So while communicating, the master will actually send the data for communication to all the slaves which are presented in the bus. But it will send with a unique number of addresses. If addresses matches, so the master will send the data to all slaves, but with a unique number of address which the slave has to be responded. So while getting the information by all the slaves, they will check first the addresses, which addresses does the master is giving. So if the slave one has the same addresses, it gets response. So if that is not the matching address, then it will check with the next slave. So next slave checks, my number is 2, whether the address the master sending is number 2. Yes, so that will be me and I should have to be responded. So if the address matches us, the particular slave will be ready for communication. If not matches, the slave will ignore the communication. Okay, so MSB will be transferred first. MSB means what? So the MSB will be transferred first in the address. Then whether the data is transferred in STA, the clocks will be generated in SCL. Okay, so this is the address transfer which happens in this I2C. So again, read and write bit. So what does the read and write bit will do here? Read and writing option, the bit is 0. Your master is going to write some data into the slave address. Okay, if the read and write bit is 0, the master is going to write something into the slave address. If the read or write bit is 1, then the master is going to read some data from the slave address. Okay, so 0 means it is going to give some data, it is going to write some data into the slave address. But if it is 1, then the master is going to read some data from the slave address. So this is the difference between read and write bit which is in the I2C. Okay. So here also in the frame we have seen about acknowledgement. So what is actual acknowledgement? After the 8-bit of transfer, the 7-bit addresses, that is 7-bit address and 1-bit read and write bit. Okay, that is the 8-bit totally called. The master will release the control of SDA line, then the slave will be capable of controlling it. Okay, so we'll release only after the 7 plus 1-bit 8-bit transfer, the SDA lines gets controlled and the slave is okay with controlling the SDA line. Okay. Then, if the slave keeps the XT line in low and 0, low 0 only, it is considered to be acknowledged, and keep SD line in high and 1, it is considered to be acknowledged as NAC. So when it is acknowledged as 0, then it is low. So it is happening. So if it is considered as 1, then it is considered as high and acknowledged as NACK. That is not processing, or the response is not given properly. That's what. So again, the clock will be always controlled by the master. There is no clarification in that. The SDA, that is the clock, will always be controlled by the master in the system. Then again, the SDA will be controlled by slave only for sending acknowledgement and read the operation. So SDA means data transfer, will be controlled by the slave only by sending acknowledgement and reading the operation. So only for reading operations the SDAs are used actually. So again, the acknowledgement has a little bit points too. That is, if the master received the NAC, if the master receives the NACs means not acknowledging, again it will send the start bit to initiate the data transfer. So if it is not acknowledged, if it is acknowledged, then the process will terminate by stopping the process. But if it is acknowledged, not acknowledged means it is not obtaining the, not receiving any information from the master, or the process data is not processing. Likewise, it will give NACK, not acknowledged function. Then it will again send the start bit to initialize the data transfer there. Okay. Then if the master received the acknowledgement, it will start sending the data frame. So if the master received any acknowledgement ACK from the slave, then it will start sending the data frame, assuming that the bus is clear. So the master can send the knowledge data to the slave. Likewise, it thinks, and if it gets the acknowledgement back, it will send this data frames to the slaves. Okay. So what is the data here actually? Similarly, the data will be transferred from master to slave. Similarly, the data will be transferred from the master to the slave. For every 8 bit, that is 7 bit plus 1 bit, 8 pulse will be 8th pulse will be generated, 9th pulse will be generated by the slave for acknowledgement. Okay, so the 8th pulse will be generated for the 8 bit, and the 9th pulse will be generated by slave for acknowledgement. Is generated by the slave, is generated by the slave for acknowledgement. Okay, so this is the concept of data here. Okay, so when does the stop condition initiates? Actually, when does the stop initiates? If any data has to be sent, the master will send data byte or it will send to stop the condition. Okay, so if any data has to be sent, the master will actually send the data byte or it will send the condition. It will send the stop condition. Okay, so again the SCL, that is serial clock line, will first become from low to high. Next STL will become low to high. Okay, so first which one will become low to high? The SCL clock, the finalized initialized value, then terminate point number. First it will get, so SCL will become the becomes from low to high, and next SDL line will become the from low to high. Okay. So what are the operations here? The operations are write operation and read operation. Unless it is readed, nothing will be written. Okay, so first the read operations will be happens and then the write options will be happens. That is in the I2C. Again, bus arbitration. What happens in this? So I2C bus arbitration means when master 2 changes the state of the line to high, the line must go to the high. If the line bus does not go high, then the bus occupied already by should be some other devices which has put the bus low, such as masters nearby. Okay, so it is nothing but I2C components. When master 2 changes the state of the line to high, then the line must go high. If the bus line does not go high, then the bus is occupied already by the some other devices which has put the bus low, such as masters here. Okay, so this is mentioned in the diagram, that is the SC and SC are the two communication lines or two communication bidirectional lines which is used for communications in the I2C, and it is given to the master. From there, from one master, the initialization starts, and through the bus it is connected with number 3 slaves, and then it is connected to the master 2 of termination or stopping process. Okay, there it happens. Okay. Again, I2 by substitution. What has happens if the master gets the acknowledgement from the slave about the process, then it will send, it will write the data to the slave, and then the master too will terminate the process actually. So thus the master does not get its data on the bus for as long as there have been no stop sequence present on the bus. It won't touch the bus and leaves the SCL and SDA line alone. It will only leaves the line alone. Okay. So a rule of thumb, if the master cannot make data line to go high, then it loses the attribution and needs to back off and wait until the stop sequence is seen. So once in between any process gets disturbed, then it must wait until the next turn and has to wait the stop sequence is seen. Okay, so this is the happens when I2C bus attribution. So later it can check the line and make another attempt when the line is free. So while the system is or the wire is busy with sending other data from master to slave, which acknowledgement data. If it does not get the acknowledgement data or it only occurs the NAC, then it should wait for the next attempt until it has to check the line whether it is free to pass through the another attempt. Okay. So that is what's given here. Later it can check the line and make another attempt when the line is actually free. So some of the advantages for this I2C is actually only two wires can be used here. Okay, as I already mentioned, only two number of lines and they are bidirectional, and it has low hardware cost. The hardware using here is very low of cost. Then it has easy PCB routing. So for the PCB routing, this process is very easy and easy to maintain. So again, it supports a multiple devices. As I told you, there are two bits, 7-bit and 10-bit. So if the address is large, then it will uses the 10-bit, which has larger number of addresses. 1023 addresses devices can be connected while using the 10-bit addresses. Okay. Then again, address based communication. So that is what I told you. When the master is used to send the message to all the slaves, it will send the message along with the address of the slave. So while responding to the messages, first the slave will observe all the messages from the master to confirm which slave is used to respond with the number of address. Okay, with the unique address. So if they get the address matched only, then they will send the data or send the respond back to the slave. Okay, so again, address based communication, that is what I told you now. The low power consumption, because of this there is the power wastage is very less. Okay. So disadvantages, it is slower than SPA, it is slower than serial parallel interfacing. Okay, it is very slower than serial parallel interfacing. Then pull up registers required. Okay, it actually reads pull up register, which is actually in the bridge. Okay, Adam bridge. Okay, so it has pull up registers required. Then bus length is limited. Okay, so how do you do the best length only for short, as I already told you, it is only used for the I2C communication with using the two communication wires which are bidirectional direction, only communicates for a small distance. Okay, small distances, and then lower speed for larger data transfer. So while transferring the larger data, it will becomes very slow in process. Okay, it will get stuck or boot problems. So what are applications actually? It is used in consumer electronics. Okay, consumer means mobile phones, smartwatches, cameras. It is actually used in mobile phones, smartwatches and cameras. So medical devices means ECG monitors, blood pressure monitors, then glucose monitors. There we have used in the medical devices. Again, automatic devices, they are actually used in dashboards of a cars, climatic controlling for cultivation, then sensor monitoring for temperature and humidity. Okay, then for industrial automation means special sensors for sensoring the pressure of the machine. It is very huge process and we cannot do it manually, so for that process we need pressure sensors, then temperature sensors to be controlled by that in the industries, in a whole manufacturing unit, as it produces excess energy or generates large number of energy, so it must be very carefully analyzed. Okay, then PLC communication. PLC means PCB design or PLC, that will comes under that industrial automation. Again, in the field of IoT, that is Internet of Things, it is actually used in smart agriculture, smart home, smart healthcare and environmental monitoring. Okay, so they are actually used for smart agriculture, smart homes, smart healthcare and environmental monitoring. Okay, these places they are very much used. Okay. So as I already discussed with you, what is the I2C, that is integrated circuit, which is used for communicating in between the two wires. They are bidirectional. It has 7-bit and 10-bit addresses. For only small distance of communication it is used, and if 7-bit, it can be devised, it can have to connect to 128 address devices, and if it is using the 10-bit, then it is used for large number of devices. Okay, so there is nothing but more serious about doing this I2C in the circuits of embedded system, because as I told you, what is the actual use of this I2C? It is used for communication between larger components of devices. Okay, so that is the use of using this proxim in the integrated circuits. Okay, so you understand. So of this, the providing clock bus, both lines are bidirectional. The two wire communications are used there For there, they are using the startup process. The timing sequences which are used here are start, address, acknowledgement, data, then A and N occur. It is not applicable. Acknowledgement, that is something is error or something is getting back from that. Okay, then acknowledgement, then the stop process is done there. Okay. So the standard mode will be 100 kbps speed, fast is 400, fifth is fast plus means 1 megabit per second, high speed means 3.4 megabit per second, then ultra fast means 5 megabits per second. So most embedded systems are actually using 100 kbps or 400 Ibps. Okay, so standard or fast, these two modes are mainly used by most of the embedded systems for doing the practically problems. Okay. So actually, let's revise once again. The I2C is a two-wire serial communication protocol which is used for SDA for data and SCL for the clock. The communication is controlled by the master and received by slave devices. Okay, so that's what I told you. And each slave has a unique address. By the address only it will identify the slave to which slave it is given the message, and from here it gets the response. So the data knowledge follows the start, address, acknowledgement, data, and stop, which is the process of doing the data transfers. Okay, open I2C file used for connecting sensors, displays, EEPROMs, RTC, and many other embedded peripherals. Okay, peripherals is components. Then it is ideal for short distance, low cost communications in embedded and IoT systems. According to this only it will happen. Okay, so these are the short summary for the I2C. So I hope you all understand the section I2C, that is inter-integrated circuits. So please do like the video, and if you have any doubts, ping me in the comment. See you in the next video. Thank you.